Hello, everybody. In this portion now, we will be going over changes in interest rates and how they affect the bond values. So what we will do is we consider the following bond, which have a 10-year to maturity. It pays 5.5% annual coupon bond, and the face value is $1,000. So that 5.5% annual coupon bond is 5.5% of the face value. So 5.5% times $1,000, which is, I believe, $55. So what I did is nicely wrote these givens. And based on these, now what we want is to calculate the value of the bond, really, but depending on different required rate of returns of investors. So how much would an investor with a 5% rate of return, an interest rate, if you want to call it that way, would value the bond at? How about an investor whose required rate of return is 6%? How about 7%? And so on. So we can even extend it to 8% and so on. 8%, for instance. That would be, okay, how about that? All right, so what I will do is either we can go directly to the ribbon and then from the financial, we can find the present value. Let's go ahead and do that one like that. And the next one, I will use a different method. All right, so here we go. So the rate is this number. The number of periods is 10 years. The payments are, like we said, the product of those two numbers. So I need to write this equal to this times this. I hope that works. Oh, invalid. So it's not letting me use that. So how about this way? Okay, it lets me. So I don't have to put an additional equal sign. And the face value of the bond is $1,000. That's it. So this shows me that a person whose required rate of return is 5% is willing to pay up to $1,038.61 for this bond. Okay, now we can go ahead and make the same calculation for when the rates are 6, 7, or 8%. If these were the required rates of return, what would have been the value of the bond for investors like this? So we can, again, either go to formulas and find the related formula here, namely the PV formula, or let me show you some interesting way to do it. We can just PV, we can just write out the formula as we type it, right? So if you know the formula, equal sign, PV, open parenthesis, and then it already guides you through the steps. That's another way. Also, I think sometimes it's also possible, look, it's already telling us that it can do some automatic calculation if you want to. Let's not go there for the time being. Okay, let's just go ahead and, oops, actually, let me see if it gives the correct formula. Oops, equal to PV. All right, so I'll just do it. So the rate is this number, comma, the number of periods didn't change, comma, the payments will be this number times this number, comma, and the future value is this number again. That's it. Press enter, and that's the, oops, okay, so I think something that I was afraid of just happened. All right, the formatting, undo the calculated, okay, there you go. All right, so somehow it's affecting each other. I don't know how it's affecting each other. All right, good. Or because I kind of changed the formatting, let me just remove this formatting. Charts, color scale, clear format. There you go. All right, so no more format, I think. Okay, there you go. Okay, let's continue. So present value, oops, PV. Again, the rate is this time 7%, comma, number of periods is 10 years, comma, the payments is just this number times this number, comma, the future value is this number again, close parenthesis, press enter. All right. And actually at this stage, I'm pretty confident I should be able to, no, it's not letting me. All right. So let's finish this. Present value. If I were given another chance, I would have done this table in a different way, but fine. This number, comma, the product of this times this, the face value times the coupon rate will give you the coupon payment amounts, comma, and the future value is this number. That's it. So now what we did is we were able to relate the rates and the value of the bond. So as you guys can see, the two are inversely proportional, right? So they move in opposite directions. Whenever the rate goes up, the value of the bond goes down. That turns out to be a huge result. So let me just go ahead and construct a table for this. So you know what I will do. So let's a very simple table, I would say, right? So let's have rate. I'll just redo this because I don't like the table formatting there. I wish I didn't do that table formatting. Okay, and then value. Okay, so the value, what I will do is I will put a minus sign in front of them so they look like positive. I think it's better. There you go. All right, and I'll just drag it down. Hopefully it should work. Yes. Okay, and it's very easy to draw a graph. So we just insert. There are different type of charts. Let's see which one is the more convenient one. I would like to say this one. Yeah, why? Let's also add the lines probably. Why does it show a straight line? I'm not sure. Probably, well, it's not exactly straight line, but yeah, it seems it looks like so, right? So what I need to do now is a little bit of housekeeping. So what I can do is the dollar amounts, because all the dollar amounts are ranging between 832 and 1038. So what I can do is I can format this. Oops. I can format the axis. Let me just go ahead and try to format that axis first. There you go. So click format axis. There you go. So I can start it from, because the smallest number is 832, I can start it from 800, I guess. There you go. So that will do it. And then the interest rates, the lowest interest rate is 5%. So I can start the interest rates from 4%, I would say, right? So there you go. So the minimum is 4% and the maximum is 9%. I'm happy with this, I guess so. Let's see if, yes. So with this new, yeah, the chart is more reasonable. The important lesson in this chart is as interest rates go up, you guys can clearly see that the value of the bond declines. So it's a downward sloping curve. So as a result, what it does is it has interest rates has a huge implication in terms of pricing securities such as bond securities. The same would have applied if you were pricing any other security for that matter. If you are pricing a stock or some other security, obviously it will have an impact. Yeah, so like I was saying, it makes perfect sense for the value of the security to go down as interest rates go up. One way to recognize that would be, you might say that, hey, I'm purchasing the bond to maturity, so why should changes in interest rates affect me? Well, it does affect you implicitly for the following reason. If you were to sell the security, the bond, in the secondary market, then suddenly you realize that these are the new interest rates which will apply in the valuation of these bonds. So even though you do not plan to, you plan on holding to those securities to maturity, at the end of the day, the secondary market value of those securities are down, and for any reason, if you have to dump these securities back to the market, if you want to sell the bond before the deadline, so then you know that those bonds have a different value now because interest rates changed. So actually this is a part of the discussion in upcoming videos. So what we need to do is, if we have a portfolio that consists of multiple securities, tens or hundreds of securities, we want to find a way to at least approximate what will be the overall value, how will the overall value of the portfolio change when interest rates make small changes. For instance, on a daily basis, interest rates keep moving up and down, and you don't want to recalculate the value of the bond repeatedly. So that's what we will be doing next. We will be using calculus techniques to revalue a portfolio consisting of multiple bonds by using some really cool, neat approximation, which is basically based on Taylor approximation that we had a video in the first week. So you guys can have a look into that as well. So hope to see you guys in our next video.